Welcome to part 1 of Competency 16. In this competency, the teacher understands mathematical connections within and outside of mathematics and how to communicate mathematical ideas and concepts. In this video, we will work with mathematical connections. Number 1, which of the following subsets of complex numbers are closed under the operation of multiplication? Select all that apply. Okay, if you are not familiar with the term closed under multiplication, please stop the video and go find yourself some notes. Now, if you've seen it before, you'll understand exactly what I'm talking about. First, you have to give the form, you have to look at the form that they have presented in A, B, and C, each of those, and then multiply them to something to verify if you get that form back. So, meaning closed, meaning when you multiply it, you're going to get that exact form back. And what I did to test this is I multiplied them to themselves. There are other ways to do it, but that's a good way to do it. For example, let's say that A equals 1 and B equals 2. Let's put that in the calculator. And already you can probably see A isn't going to work. Okay, so I have 1 plus, and I set up my fraction. Well, that's going to be 2 over 2. And I'm going to multiply it to itself. So I square, and you get 4. Now, there was another person online that took it a little further, so I'm going to do what they did. So I'm going to say I have A sub 1, B sub 1, and then A of 2 and B of 2, and call that 3 and 4. And I'm going to set it up that way and multiply and allow you to see that. Okay, so that's 1 is A plus, then my fraction, and I have 2 over 2, okay, which obviously you already know what that's going to be. Okay, now I'm going to multiply it to 3 plus 4 over 2. 3 plus, and I have a fraction, 4 over 2. And I'm sure you can see that it's still not going to be closed under multiplication. We get a different presentation. You get an actual integer, a positive integer. Okay, so the truth is there is no way that that form is going to be closed under the operation multiplication. Okay, so therefore A does not apply. Now there is something else, another way that I want you to look at this, which some of you may have seen right away. This actually implies that you have A, B over squared. That's a mixed number. So it is what it is. There is no way that you're going to get that form back. Okay. Now let's look at B. I'm going to say that's a selection because we're going to use a calculator, and you will see every time the square root of 2 will be that form. Now, we're not looking at it the decimal. Yes, you could turn it into a decimal. Well, you could turn A into a decimal. This is not what we're looking at. We are looking at that square root of 2. Let me show you what I mean. Let me clear that out. Okay, so now let's go with 1 and 2, the A of 1 and the B of 1. Okay, that should be good enough to prove our point. So we have 1 plus 2 second square root, and it has to be 2 under the square root every time. Arrow over, square that, because we're using multiplication. Press enter, we get the form back. No matter what you do, you will get that form back. Now, you can try it with 3 and 4 as A2 and B2, okay, but you're still going to get the same thing. So, yes, B is an option. Now, let's look at C. Well, that is the same situation as B. If you have taken any classes where you worked with complex numbers in depth, you would know this. So let's square that. So, and then what I'm going to do, if you square this, A plus BI, oh, I could write a little better than that. Let's see if I can here. All right, let's use A plus BI, and let's square that. This is going to equal A squared plus 2AB plus B squared, but then you're going to have the I squared. Okay, the I will be squared too. Well, I squared is -1. Okay, so when we put all of this in using just, if you have A equals 1 and B equals 2, what comes out in the wash? Well, let me show you what's going to happen. First, you're going to have 1 squared. Well, that's 1. Okay, so 1 squared. Now, I am going to give you the values here and here first, okay? Well, you can, because those are going to be integers, you can just add those together, correct? Yes. So plus, well, what is B? B is 2. 2 squared, and then you have to multiply it by the I squared, right? Which is -1. Well, that's going to give you a -3. So what do we really honestly end up with? We end up with -3 plus. Well, that's 2 times 1 times 2, which is really 2 times 2. That's 4I. So you're going to end up with that same form because that's just how it comes out, which is basically the same thing as what happened in B. Okay. This is a situation where you can use your calculator to test the waters. However, this particular scientific calculator, we do not have a button dedicated, a function dedicated to I, and we do not have a function dedicated to absolute value, which leads us to number 2. Okay. If f of x equals the absolute value of ax minus b with the points 0, 6, and 2, 0, what is f of 8, meaning when x equals 8, okay? And they give you an image to help you, okay? Now notice the part of the image is cut off, okay? And this is absolute value. There's a couple of ways to see this, but because of the nature of the beast, meaning that you have a function, let's put this in the calculator so I can show you very quickly what we have. Look at your image, which I was given a question like this on a practice test at the university. Okay. And if you're currently going to take a practice test at the university, uh, this, you may even see this very item. Okay. So there's, you can see that you can make your equation, right? So we have B, our B value is 6. So here, let me clear this out. Let me push table, clear out what we have. What do we have? I see -1, 2, 3 over 1. So that's -3x plus my 6 B value. Okay. I built the equation off of the given. Okay. You could have done it off of the points, or you could have just done it off of the image, either one. Okay. So I did it off of the image. Okay. All right. So you could play around with that. Now, I'm going to back out and use a table to show you how to get it with a table. Okay. So I'm going to say, now that'll be saved in there. I'm going to push enter to save it. Now I'm going to back out. Okay. So let's go data and push data again. Go up to number 4. I'm going to clear all. Okay. Put those 2 points in there. 0, enter. Okay, my X's are, if you've watched other videos with me, you know what I'm doing. These guys right here will be my L1. And then these guys right here are my Y's. Of course. Oh, I wrote 2 and I meant 1. Oh my goodness. I'm so sorry. This will be L1. This will be L1. Then this will be my list 2. And this will be my list 2. There you go. All right. So I need to put 2 in next. Then I need to bounce over. Well, it needs to be 0, 6. So 6, then enter, then 2 and 0. Okay. So now you really need to back out all the way. I've explained this in other videos. So second mode to back out, right? Now I push second stat and I need 2 variable because I have an X and a Y that I'm dealing with. So that's number 2. Okay. Now I have my data in L1, then L2, precisely like I have it labeled. So I'm all good there. I have the right setup. Now I go to calculate, push enter. Okay, you have to arrow up or down. I'm going to arrow up. You get to your B and your A and your B right here. See how my A is -3? Well, that is my M. That's what I had. A, which is my slope, equals -3. B, of course, equals 6. Well, that's what's in our image. Okay, so if they don't give you the image, use the calculator. Now, there is a mild glitch here. Everything's supposed to be an absolute value. It is given to you as the absolute value of that. And the image shows you the absolute value where all things are supposed to be positive. Well, guys, let's go. I'm going to go to second mode. I'm going to go back to my table. I'm going to go through the motions with my table. Okay? And I'm going to start 0, 1. But what I'm going to do, actually, it didn't matter. Here, I need to clear out my buttons so you can see everything I'm pushing. Okay? All right. So what did I do? I pushed table. I entered my equation in. Now I need you to see that I have ask X highlighted. That's what we're going to use. And what are we going to ask? We're going to ask for number 8. Okay, so I'm going to push delete to clear everything out. You only have, it's called a multi-view calculator. It's only going to give you 3 lines, by the way, but we only need 1. So push 8, enter, and without, now remember, none of this was in absolute value. So it gave me -18. But if I put an absolute value around that, what would I have? I would have a positive 18. So all you need to remember is that you can put in the equation that you built, but at the end, don't ignore the fact that here, I'm going to use a yellow here. Okay. Don't ignore the fact that you have absolute value. Just put absolute value around that, say absolute value of -18 right here, and you're fine. You'll be good to go. Unfortunately, our calculator doesn't have that functionality, and you won't have that on this test. Now, for those people using the TI-84 for the 7 to 12 examination, they have that. Okay, the nice convenience. Unfortunately, for us right now, that's not going to be an option for us. Okay, now let's go to number 3. I actually really like number 3. Okay, I'll explain to you why. A student claims that the equation square root of 2x squared plus 28x equals x plus 8 has 2 roots using the following steps as proof of the claim. Okay. And this could be actually under some of the other competencies, but it's also under this competency. So take that in mind. Okay. You're evaluating what a student it does, but what it's also is you're making a mathematical connection. That's why it's under the connections. What are we connecting it to? Well, we're connecting it to simple rules that we should know and understand. Okay, but we're going to use a calculator to get there. So this is what I want you to do. I want you to clear out. And yes, we are going to use the table function here. So, oh, here, I'll show you how to get to the first of it. Clear. I use second mode to back all the way out. You can clear and go backwards, but I'm going to have us all the way cleared out. Okay. Push table. Okay. Now clear out. However you want to do it, you're going to get there eventually. Okay. So let's put in what we see, except we need to make a little change right here. Okay, so this is what we're going to do. Second radical 2x squared plus 28x. Now back all the way out, arrow over, so you're no longer under your radical. Okay, now subtract, and then in parentheses, you're going to subtract this entire right-hand side, and you're going to make this equal to 0 really quick, okay? But you have to put it in parentheses because you want the whole thing, okay? You're going to move the whole thing to the other side of the equal. Okay, so we had x plus a, close your parentheses, okay? That's the expression you want in the calculator. And we are going to look for what equals 0. And I want to show you what happens, okay? Enter. And we're going to use ask. Everything that's set up here is exactly what we want. Okay, and I'm going to delete out. Now, I have it in my calculator, but what do I need to ask? Well, let's look at what's going on here. They took, squared both sides. Step 1, they wrote down the problem. Step 2, they squared both sides. I absolutely agree. And I agree with the findings. Perfect. Then what did they do? They moved everything to the left side, leaving it equal to 0. That's essentially what we've done. Okay, we have done that. But when they did it by hand, the way that we're taught, they end up in step 4 with x equals negative 16 or x equals 4. And this is where most people stop, and a lot of educators stop. Do not stop there, and I will show you why. Everything you've done is perfect. Everything the student has done, and you probably sat and did it by yourself, by hand. You probably stop the video, work it out for yourself. That is what you're going to get. There is nothing wrong with it. Just one thing. Okay, I'm going to do this. I am going to put both of those in my calculator. Negative 16, enter. You don't get 0. Therefore, it is incorrect. I'm going to put 4, enter. You get 0. So something is amiss. This is incorrect, where this is correct. Well, let's read our ABCD options. And some of you probably saw it right away and you're like, wait a minute, you had a square root over there? So something's going on. Because the truth is, when you take something out of the square root, you have a positive negative situation. Anyway, let's read on. There is an error in step 2. No, there are no errors in your steps. B, there is an error in step 4. No. Step 4 are the solutions, so I disagree with that. C, the proof is correct and the equation has 2 roots. That is not true. We put it in the calculator and tested it, and there is nothing wrong with the way that we put our expression in. So something has to be amiss, okay? All right, so that's not right. Okay, but I will agree with this part. The proof is correct, but there are not 2 roots. Let's read D. There is no error in the proof, but the proof is incomplete since the values in step 4 were not checked to see whether there are extraneous solutions. Number 4, use the following diagram to find the area of the circle shown. Okay, you may have already seen what it is. Visually, you should see that the radius equals 2, and the formula of a circle is the radius squared times pi. So what is that? 2 squared pi. That is the formula for this circle. Push enter for pi. Okay, now this may seem like a super simple question to you, but it may show up maybe in a little bit different form, but always be ready for something simple. They might actually put it in, let's say, a square and present it a little differently instead of in this diagram and just give you the center of the circle as 3, 3, and say the center of the circle is 3, 3, but the side length of the square is 4. There's a variety of ways to ask this, but you need to know it. Don't forget that if you forget your formulas, this formula is on your formula sheet. Okay, let's go to number 5. Talking about some things being a little simplistic. This question, this very question, in a little bit different form, was on one of my real tests. I'm not going to tell you which one, but be ready for something like this maybe. Using the diagram, find the value of C if the area of the figure is 76. Well, the first thing that you need to do is you need to subtract out the area of the square, because in order to solve this, we will need the Pythagorean theorem. And we know this is 4. We need to know this height. And we know that this area here, okay, we also know that because of these little marks, that each of the sides is 8. So that means that that triangle has a base of 8. And we know the entire area of the square is 8 times 8 is 64. So this is what we need. We need the area of the triangle. Okay, so 76 minus 8 times 8, 8 squared, gives me 12. So the area of the triangle is 12 units. So now I'm still need that height. Okay, base times height divided by 2 equals 12. Okay, so 8 times h, divide that by 2, equals what? Well, that's going to equal the 12. That's what's in our calculator. So now I need the height. Okay, well, there's a couple of ways to deal with that. You could say we could go ahead and divide this out. Well, 8 divided by 2 gives me 4h with 12 divided by 4 on both sides. Oh, here, let me make this. Oh, sorry about that. Let me make it a little bit clearer. Well, this is gone, so h equals 3. Okay, so my height's 3. Wait just a second. Interesting. My height equals 3. That is a 3, 4, 5 triangle. I can already see that option B is correct. Okay, but let me go ahead and just pop that in the calculator for you so you can see it. Now, before I do that, let's read right underneath the image. What does it say? Image is not to scale. Because you may look at that image and say, wait a minute, that height should be greater than 4 because it looks taller. No, never go by that. And it's very specific for us by saying that it's not to scale. So that tells you to ignore that and pay attention to your numbers only. That's something else that you're probably going to see on either your practice test at the university or the real test. And I do remember some images in the real test having that notation below them. Okay, so let me pop this in the calculator. So I need second radical. I'm trying to find C. And this is a very classic triangle. So 3 squared, okay, plus 4 squared equals 5. So option B has been verified. Okay, let's go to number 6. Number 6, in the following diagram, the area of the circle is 25 pi and theta equals 53.14. Okay, this particular question, I can already tell by the diagram and the given, it's trying to test your basic knowledge. And I've had this image in another video also. Not quite what you're seeing here, but very close. And the question says, what is the length of segment GF? Okay, so we're trying to figure out this. Okay, now we already know what the radius is. They gave it to us. Because how do we know that? 5 times 5 is 25. We just used this in the last question. Okay. This is why this section is called mathematical connections, because you're supposed to be seeing the connections and then it connections to what you're doing with simple properties. For example, this property right here. This property right here for theta, this tells me, because of that, that we have a a specific right triangle. Okay? And notice how they're giving you that right triangle for G right here. That's just a property that occurs when we have the diameter as the hypotenuse of our circle. And we are being given r squared. And because that equals 25, we know that r has to be 5, okay? So I know this is 5 and this is 5, and the entire thing equals 10. Well, what I'm seeing is 2 times 5 equals 10. This tells me that I have a 3, 4, 5 right triangle, which is what we just had in the prior number 5, the prior question, and it's everything is just multiplied by 2. Okay. Well, let's see if I can get you to believe me. Okay. How could we solve this? Well, we could use the properties of sine. Okay. Go to your formula sheet and use the laws of sine. Properties are laws of sine. So let me write that out for you. Let me show you what we're doing here. Okay, so what do we have? I'm going to use the fact that we have G that I've circled, okay? I'm going to use sine of 90 degrees over, and you go straight across from that, and that entire length across from 90 degrees is 10. And then, okay, this is degrees, okay? And then we set it equal to what we know or don't know. Well, I need to find GF, and I'm going to call him B, okay? Well, I need to find B. Well, I have this value here of theta. Well, then I need to say sine of 3.14 degrees. Okay, so now what? Well, you need to know this property. What does this equal? Actually, that equals 1. Oops. Okay, but let me line it out for you. I have the sine of 90 degrees, okay, times B equals 10 times the sine. Actually, let's not use the parentheses. Let's actually use our multiplication in the calculator. Sine of 5, 3.14 degrees. That's what I want in the calculator. But you're saying here, this might clog me up. Well, Yeah, we could go ahead and divide by that, but we're really going to be dividing by 1. Okay, well, let me write it down. Okay, I was going to put equals 1 there, but let's not do that. I'll just show you that. So sine of 90 degrees, and then sine of 90 degrees. Okay, so this gives me actually something pretty clean to put in the calculator here to give me what B equals. And B is that highlighted length that we're looking for. Okay, all right, so let's put the whole, I'm going to put the whole thing in the calculator and then I'll come back and show you, or you can go ahead and pop it in the calculator. Oh, you know what? Before we do that, go to mode. Make sure you're in degrees and not in radians, okay? If you have radians highlighted, go over to degrees, push enter. Then second mode to back out, okay? So I'm going to set up my fraction 10 times sine of 53.14, and I like to close my parentheses and then go down and say sine of 90, close your parentheses, push enter, and that is actually 8. Now, yes, there is a small discrepancy error. That is because our estimated 53.14 degrees is actually an estimate, okay? So that tells us that we're looking for option D. However, I do want to point out a couple of things. One thing I want to point out to you is that C could not be an option because just from common sense, we know that B is not going to equal 10 because then we would not have a triangle. It's kind of a trick question, okay? All right, now then you could also maybe use a little bit of rationale on 6 or 3. However, let's take a look at sine of 90. Okay, remember I said that equals 1. So let's check that out. Sine of 90. That equals 1. That's what makes this setup so nice. So what we could have done is simply said 10 times here. Let me use a different color. B would just simply equal this right here. Okay, and we don't need this because it equals 1. Okay, you could have just popped in times 10 times the sign 53.14, and it would have gotten you there perfectly. Okay, all right, but also remember that you will have a little bit of a rounding error there, and that's what we're seeing here on our calculator. So let's look at number 7. Okay, the grid shows the function g. Okay, given that f of x equals x and g of x equals a times, that's they're multiplied together, so you know, a times g of x. What is the value of a? Okay, they're just trying to confuse you with rhetoric, mathematical jargon. What does g of x really equal, guys? A times x. I'm going to stick a y there. Does that somehow look very familiar? Yes. This would be a linear equation or linear function. Don't let it fool you, where a is equal to the slope. So all they really want to know is what is the slope of this image. What is the slope of G? Because they're telling you G is in the picture. Well, look right here. Use this dot, or you could use this dot, but start at 0. Yeah, sure, you could go from dot to dot, but why would you? Okay. What do I see? I see a positive slope. They don't have anything negative over here. And I see a rise of 1, 2, 3, 4, 4 over. the run and I see 1, 2, 3, 4, 5 here. Let me use the highlighter to show you the triangles. Or, okay, I'm going to write 5 down. Or we know that that would be 8 over the 10 because it started at 0. You can do that. And just pop it in your calculator if you don't want to make any errors and you see that it goes through 0. Just do your y over your x and it gives you 4 over 5. So you see, option C is exactly what we need. They're just trying to get you lost in the math, the mathematics, the communication of the math, and see if you make that proper connection. Okay, right. This is the last question in this video. Thank you for watching and making it to the end of another one of my videos and listening to my little extras, my rambling. I hope some of my talking is actually helpful for you. Thank you for liking, subscribing, and sharing us. It really is great, guys. Thank you so much. Okay, happy testing, everybody.